How's everybody doing?
Good, right?
It's very lopsided on this side tonight. That's cool though. That's where the pizza is. Anyway, I'm Ethan, talking about getting data out of microservices, Cqrs projections and rendering UIs. There's a lot of faces I don't recognize here, but basically I never shut up about event sourcing and microservices. And this presentation tonight, though, is like the payoff of all of it. I think this is the most exciting part of doing evented architectures, mostly because how we read data is far more interesting than how we write it. And we're going to see some powerful stuff here tonight. So hope you enjoy it. Anyway, let's have story time. Super interesting story. Kind of my path through web development. It will relate to the topic at hand, but if you can't tell, I built this site in high school. This was back when you had modems to connect to things. And I stayed home from school one day to do some homework, but instead I made this little button right here. You'd click it and it tells you how many times you clicked it. And the thing is I don't remember what homework I was supposed to do that day, but I do remember making this, and honestly I think I made the right choice. Anyway, so my first real foray into web development, I worked at BYU in the financial aid office as their webmaster with some mystery piece here that equaled pure magic. Any guesses what that mystery piece is? PHP. Why was it pure magic? Well, with this hideous thing, I had to edit code to change what showed up on the screen. But with PHP, I could connect to a database and populate a select list from there so I could get different stuff without changing code. And my mind was blown. This was the coolest thing ever. And of course, here's what my code looked like. Database connections on every page, etc. If you've done PHP, you know what I'm talking about. Unless you use one of the frameworks. I didn't. Has anyone worked with, what is it, Cake or Laravel? No?
I've done both.
Okay.
The version that you did originally.
Okay.
I was programming PHP before the frameworks were around. Programming in Laravel is a very different beast than writing that stuff.
Okay. Did it clean it up though?
Oh, a ton.
Okay. That's good.
When you and I were first writing PHP, you would render your HTML and your CSS and your JavaScript inline.
Yeah.
Your actual PHP processing code. You don't do that anymore.
That's wonderful to hear, because it was messy.
I would argue, like most of your backend languages, just like Node, right? You're not rendering your front-end stuff. You're not rendering the HTML and front-end JavaScript to run stuff. You're running an API, and then you're completely separate for the other stuff, so it's not so bad. Sorry.
Right. No, that's cool. I'm glad to hear. I really wasn't aware of what the state of the art is right now. In any case, though, after that, I went and worked for a company called National Instruments in Texas doing device drivers, which is about as far away from web development as you can possibly get. But it was fun. Anyway, from there, though, I got a job using Ruby on Rails. And if my mind had been blown by the select box that could be populated from a database, this was just pure magic. Because literally, in 15 minutes, you could have an app up and running. You just give it the name of a database table and the columns that you want, and suddenly it generates code for HTTP handlers and how to persist things. And I thought that was amazing. And I worked in Rails for quite some time. But there was always a problem I noticed with Rails apps. I ripped off this graphic from Wikipedia on exponential growth. On the x-axis is time, and on the y-axis, the difficulty of making changes. And I would say that Rails kind of follows an exponential curve here. Really, really easy to use at first, but then suddenly it just becomes more and more and more difficult to make any sort of changes with any degree of confidence that you're not breaking something else in the system. Whereas the kind of stuff I do today with microservices, I'd say, is either more like the red or blue, more difficult at first, but it ramps up much more slowly. So if your app spends its whole life cycle in this part, then a tool like Rails is a fine choice for it. But if it's going to last for a long time, I don't think it makes a lot of sense long term. But I'm not here to just pick on Rails, because it's not. Rails is a fine implementation of the kind of architecture that it is. It's the problem with the architecture itself. So here's a bunch of nodes. Here's two nodes. They have one connection between them. If I add a third node, I get 3. If I add 4, though, I get 6. And when I have 6 nodes, there's 15 connections between them all. Obviously, when you add node n, you add n minus 1 connections to it. But in a sense of software, these things are all interconnected with each other. If I make a change to any of them, I potentially have to make a change everywhere. And that's kind of the essence of the monolithic architecture that Rails is. I've used this slide a number of times. This is my representation of a monolith with a database in the middle. It's all in the same operating system process, called out to concerns. It's function calls between the concerns. Most writing I've seen on microservices says to do this. So just take chunks of code out, stand them up on their own server. I would contend that's still a monolith. It's just a distributed one. So you get all the panes of a monolith with all the panes of a distributed system. And it's just full of coupling. 3 kinds I'd call out. Temporal coupling. Let's head back to this slide real quick. If I need to check users to do something in products at the time a request comes into products, listing better be running when I need to do that, or else effectively I am down as well. I can't do my job. So that's the temporal coupling. Spatial. I have to be able to reach it. So like the data center, the VPC rules, whatever, have to be set up to allow me access to that. And then the last one I call shape coupling. Users better emit data in the same shape that I expected. It is not free to change because I am now coupled to whatever representation of it gives me. And that is the essence of what makes something a monolith. It's not running in the same process. It's not being a large code base. It's not running on a single server. It's how coupled you are. So these are often presented as different things. In the JavaScript sense, I would say they're double equals one another because there are significant enough implementation details, but howdy, they're the same thing. And here is a scene of a developer conference from the Fellowship of the Ring when Saruman is commenting on Gandalf's monolithic architectural choices. That's what they were actually talking about at that moment of the movie. Anyway, so what makes something service-based? When we talk about microservices, what does that actually mean? And autonomy is the essence of microservices. What do I mean by autonomy? 3 points here. No one asks a service for anything. A service will never have a get API on it. We have components, architecturally speaking, that you ask questions of. Those are called databases. The act of asking them a question is called querying. And a database is still a database, even if you wrap HTTP around it. In fact, databases like SQL Server and Oracle ship with HTTP capabilities right out of the box. That doesn't turn them into anything other than databases. So services are not databases. APIs are not services. When I say API, I mean in the sense that we probably think of them as web developers, some server running somewhere responding to HTTP. Those aren't services. You don't get things from a service. Second, they don't ask anyone else for things. If they did, they would depend on that thing. So going back to our example here, products can't be a service because it depends on users. So if users is down, products is down. If products were autonomous, it wouldn't depend on anything. So users could be burning and products would be able to do its job just fine. And then the last one's kind of a corollary of the other two. A service really isn't even aware that there is anything else in the system. So to illustrate that, here's an alternative approach to the node thing we saw. What if instead of having all these nodes connected to one another, they were all connected to mystery box? 6 nodes, how many connections there? 6, right. If this one changes, does it affect this one? Doesn't, because it doesn't even know that one's there. So ask the question, in a full system like this, or that node by itself, can that node tell the difference between these two scenarios? Not at all, because it's autonomous. And speaking of wanting to know answers to things, here's random meme for your enjoyment. I like memes. Anyway, okay, so what is that thing in the middle? You might have heard the term event store or event bus. Those are two different terms. You could use either one, but let's compare them a little bit in just a second. Whichever one you go with, the general idea is if this needs to communicate something to the outside world, it just communicates it to mystery box, and then the other components can receive that from the mystery box. So this doesn't know that 5 other things are listening. It just knows about this, and it publishes a message that these will pick up and may or may not care about. So what's the difference between the two? Both of them act as message transports, meaning I can move something from point A to points unknown. However, in an event store, we hold on to those messages because those messages become the authoritative store of state in the system. Rather than our relational database tables that we update on the fly, we actually store the events themselves. And tonight's talk is about what do we do with the events once we've stored them. But in an event bus, we don't retain the messages. It's just a transport. Examples of that, Kafka, RabbitMQ. An example over here is a project actually called Event Store. And a couple months ago, I did a presentation on building a simple one of these using Postgres. I'm sure it was exciting, but we did it. Anyway, so we're going to be talking about using one of these tonight. And now one important distinction. When I talk about events, especially with a group of Node people, I have to be clear what we mean here. I'm talking about domain events, which are interesting things that occur in your system's domain. So if you're e-commerce, you might care about users registering or item added to cart, order placed, payment received. Absolutely not user updated, user created. The CRUD verbs have no place in domain events. Those are database operations. They're not domain operations. Howdy. Good to see you. And this is also opposed to what I'll call mechanical events. So like button clicked, window resized. In the Node world, hey, I finished reading your file, here's its contents. Those I'll call mechanical events. They're not really interesting things in your system's domain. They're important from a technological standpoint. Like if you have to read a file to serve an order, you'd like to know when it happened, but it's not really the state of your system. Does that distinction make sense? Any confusion on that? Okay, good. So yeah, domain events are records of interesting state transitions in your system. You define them. Depends on what your app is. If you're not e-commerce, you obviously won't have item added to cart. Why is that so important? Imagine if you have to debug a live issue in production. Which of these lists of events would you rather have? Yeah, this doesn't tell you very much. It would be like a whole bunch of git commit messages, but they're all empty. Like, sweet, a commit was made. I have no idea what the intent of this was. Sure, I can look at the diff and try to divine it, but we'd prefer to have that. But there's a problem. There's always a problem, right? If we're storing streams of events, that's all well and good for writing, but I want to render web pages to the user. I don't want to show them a list of events unless it's an audit screen. I mean, that's a valid screen to have. But if we're storing things like this and you want to look at your user profile, this doesn't look anything like this. How do I take this and get it into the right shape for rendering UIs and other things? That's what we're talking about. That's where the concept of Cqrs comes in. That stands for Command-Query Responsibility Separation. It was coined by a guy named Greg Young, and he always said that when he first started it, when you Google for Cqrs, it would say, "Did you mean cars?" It took a while for it to catch on enough for Google to realize it wasn't just a misspelling. But the short of it is, we use a different model for writing data than we use for reading it. And so in this case, we write data this way. All writes are just writing events. It's really simple. You can do this in a flat text file if you hate yourself, but technically it would work. Just the idea, it's an append-only log of immutable events. You never delete them, you never change them. And so that's how we write, but how do we read? Just one little note here. You can use Cqrs without event sourcing. Event sourcing is this just write the events part of it. Cqrs in general just means different write and read models. So you can do Cqrs without event sourcing. I suppose technically you could do event sourcing without Cqrs, but it really, really benefits from using it. So let's talk about these read models, and notice that's in the plural. If I have this list of events here, this stream of events for this given user, that could mean different things to different parts of my system. For authentication, I probably just care about the email address, the user's ID, and a hash of their password. That's all I need for authentication, right? I don't need any other information. But if we recently had a data breach at the company, and I wanted to see, wait, which users have updated their password since that data breach? Well, this is another view of this same data that makes sense for that use case. So I can do whatever view of this data I want to for whatever my problem at hand is. This is super useful in a microservices setup. Because what if you have different components, say, dealing with users, and they each need a field, but they want to use the same field name to mean different things? If I'm just storing one representation of a user, they can't do that. But if I'm storing a domain event of what happened, they're free to interpret it however they want to. So there's this flexibility there that you don't have otherwise. Here's an example of Cqrs. Hopefully we have enough diversity in this room for it to work. Who here prefers cats to dogs? Who here is willing to pretend that you prefer cats? Thank you. Okay. So we're going to go with the rest as being dog lovers. Imagine that a cat just walked into the room. So this is our domain event, cat walked into room. If you're a cat lover or pretending to be one, what mental image does this conjure up for you?
I have no idea.
It's hard to pretend that, isn't it? But it might be something along the lines of like, oh, that's a cute kitty. I really like this thing that just walked in the room. Howdy. Dog lovers, what image comes to mind when you see a cat walk in the room? Yeah, exactly, right? Was the event any different for those two views of the world? No. But you have different interpretations of it that suit your needs, or pretend needs. Thank you for being willing to. I know that's a hard thing to do. I struggle with it. Right? Same data, different views depending on what you need to do with it. So this next bit here is just kind of the general layout of what a system like this looks like. There will be services in a microservices system, hence the name. They are doers of things, not representations of things. There will be some sort of an application layer that handles HTTP requests, talks to the user. It can issue commands and events to an event store. Services pick those up and respond accordingly. The application renders screens to the user based on what we call read models, and you can have multiple of them. Read models in turn are populated by aggregators, which are a lot like services, only they consume events and output read model data. And I have to be that generic about it because there's all sorts of things you can do with that. And yeah. So one caveat, in a microservices system, there's nothing about the architecture that implies that you're dealing with something distributed. You can do services that run in the same operating system process. For tonight, we're really focusing on these pieces here. How do aggregators work? How do they populate read models? What kinds of cool things can you do with that? So let's look at some code, shall we? That's fun. Any questions so far? Sorry, I mean, that was a whole lot of, I don't know, theory dump or whatever, but any questions so far? I'll stand awkwardly for a couple more seconds. Yeah?
I got one. When I came in, you were saying there's no get command in a microservice, is that right?
That's right.
But they're somehow, in my mind, the way it's drawn on the board, like they're getting info from the event store. And what's the difference? How is that not a get?
Yeah, that's a fair question. So there is a little bit of a mental shift there. I mean, they don't expose a GET API themselves, so no one directly requests information from them. But they do have a communication channel to the event store. But that's it. So they don't talk to other components in the system. There's just kind of this channel they receive commands on and emit events to.
Okay, thank you.
Awesome. Yeah, that's a great question. It's an important one to understand how that works. Any others? No? Okay, let's look at some code and have fun with it. So Let me know when this is big enough to see. Is that good enough right there? Okay, sweet. So what do we have here? Let me start this amazing server. Sorry, AJ. I know that URL offends your sensibilities. But I didn't have any friends not letting me do that. Anyway, here's this amazing web page here. GDoom is getting data out of microservices. I can register for it and log in and whatnot. That's not what's interesting here, though. Real quick, where is this? Register users. Here we go. So this is a file. This handler right here is where if I were to fill in that registration form, it would hit this function. And that hits this register user function up here, which just does a quick validation to see if there is already a user in the system with that email address. This is pulling from one of the read models. They're eventually consistent, but that's fine because what really is the likelihood that two people are going to register with the same email address in the same 100 millisecond window? Pretty low. So if there wasn't a duplicate, we're just going to assume that they sent in good credentials because we don't want to get distracted with the validation in this function right now. But basically, we just create an event, which is just a regular JavaScript object, and publish it to an event store. And at that point, we've captured that a user has registered. However, again, like we said, the event stream is a terrible read model. And if I want to authenticate this user, I need to be able to look them up quickly by the email address that they're going to supply. So how do we fix that? Well, that's where an aggregator comes into play. An aggregator is like a service, and like all service things, you just register handlers for different types of events. So this user credentials aggregator has a handler for user registered events. And so if it gets one, it's just going to call this function that will insert into this user credentials table, which has 3 columns in it, an ID, an email, and a password hash. And I mean, that there is the essence of Cqrs. I published a user registered event. Now I have this aggregator that picks it up and does something with it. So let's see that in action real quick. I can register here. And this is great UX. It tells me I registered. But let's look at what happened here in the database. Can I make this bigger? Sweet, look at that. So I'll connect here. And Postgres, schemas, public. Wait, that's the wrong one, isn't it? One of these is a test, and the other is not. OK, this is the one we want right here. Tables. OK, there's a few tables in this system. This one here contains all the events that I've emitted. So there's a system initialized event I emit when the system first starts up. And then here's the user registered event that came in when I submitted that form. And here was its payload. So this LOL in front of there is my cool hash function so that I'm not storing the password in plain text. It just puts LOL dash in front of it. And then the email address I submitted. So that's the event. But what do we do with the event? Well, just to review again, it gets picked up by this thing which says, hey, if I get a user registered event, here's what I do with it. I insert something into this read model user credentials table, which is right down here. So if I view all the data there, boom. That probably looks really familiar if you're used to doing monoliths in relational databases, because here's just a table with an email and a password hash. So now if I go to authenticate, I can easily look up by email because I have that, and I have all the data custom tailored to authenticating. And you're probably thinking, wow, that was a whole lot just to authenticate. We're just doing this one first. Any questions about this so far? Anyone get lost in that? What was going on? OK, let's look at the next thing. So let's go back here. Now, of course, GDoom is the best e-commerce site on the whole internet, and Jeff Bezos is shaking in his boots over this one. And we have so many users and products in our system. We have an admin dashboard, and we want to see how many products we have in there. So let me make sure 2 things. Okay, good, that's right. Well, let's have a look at this admin dashboard. So when someone wants to load the admin dashboard, I need to query 2 things. I need how many users are in the system, how many products are in the system, and that's all the dashboard's going to show right now. To simulate how awesome and heavily trafficked this site is, I put in this delay of 5 seconds when running the query, because we have to table scan the millions and millions of users and products that we have. So that's simulating doing that. And so we go to the admin page, 2, 3, 4, 5-ish. Did it do those? There we go. We have 1 users and 0 products. And that took a really long time. Why? Well, because it was table scanning everything, right? We have this cool denormalized database with all of our users each in a row, all of our products each in a row. And those are really useful schemas when you're doing ad hoc queries. Like in a data warehouse, that's really good. That's what you want. Question, is this page an ad hoc query? Do you not know what data is going to be needed for this? You know exactly what data you need for it, right? So why would I bother scanning the whole table each time to render this one page when I know exactly what needs to be on there? Could I not pre-compute that? I could. Thank you. And I would do that, of course, with an aggregator. So check this out. Admin dashboard aggregator. If I want to render the admin dashboard, I just need to listen for products coming into the system and users registering. So I have event types for those. Whenever a product is added, I emit a product added event. And similarly for user registered, remember the user credentials aggregator needed to record an email address and a password so I could authenticate later. But that same registered event has a lot of meaning to this dashboard. So whenever I get one of those, I just increment the appropriate count. Now that's a big blob of SQL right there that we can treat as a black box. But basically what it's doing is letting me atomically incrementing a count in a JSON column in a Postgres table. So rather than load it out, increment it manually, and then save it back in another query, I can just do a single call here that's like, hey, whatever count you have, just bump it up by 1. So when a product gets registered, I just bump the count. When a product gets added, products don't register themselves. Bump the count. Same thing for the users. Oh, but here's a problem. We didn't notice this performance problem until after this had been in production for a long time. So I've been missing all the events that started from the beginning. Uh-oh, what do I do? Well, it's a good thing we were event sourcing, remember? Because we store all those events as the authoritative state. So I still have all the original source data, right? So when I start this up, let me turn the admin dashboard aggregator on. That'll restart the server. Give it a second to get caught up. And then I hit admin better and I'm going to click it right now. Why is this going so slow? This is not impressive. OK, it is faster. That has nothing to do with the query and everything to do with the system right now. Maybe it's because I don't have it plugged in. All right, so here's the old one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. And then admin better goes at least a little bit faster.
So are you like loading 10,000 CDNs? It doesn't even look like you have any styles. What is it taking so long to connect to?
Hey, maybe that's what it is. There are a few CDN calls, and I'm not actually hooked up to the internet. Hey, that would be so great if that's what the problem is. Because I wasn't doing this at home. That's not a great excuse. Works on my box. Yeah, there we go. See, these are timing out.
Yeah, don't ever use CDNs.
For this very reason. OK, so it's the CDNs that are causing this to run slow. Anyway, the point is, because I can reshape the data into whatever shape I need for my application, I can have aggregators dedicated to particular screens. So I could take this even further. I don't have to take the data and put it in a database, given that this is a static page. I could just generate a static page in response to an event and then just serve that outside of my web server. I think that's pretty cool. The last thing that I'm going to show here is we have products, and the CDN's timing out, but we made it. And I can add products like the slap chop. What was it? Don't have boring tuna. I can add that. Product added, yay. Oh man, you're totally right about the CDNs, AJ. This is killing me moving here. 2 seconds to change. I'd have to download the files, right?
Just comment it out because it's not loading anyway.
I'm getting it from cache. Whatever. What can you do with a hamster? You can't eat that, but you can look at a hamster. These are great descriptions, and I know you're all pulling out your credit cards right now to buy these. And then ham, you can eat that. You can eat. What was that?
Don't eat a credit card. There's no price there.
Oh, yeah, good point. See, that's why this is such a popular site. Now, I want to be able to search products, and sure, relational databases can do full text search. And if you have a small number of rows, it'll work just fine. But are there things way better suited to full text search? Who can name one? Aaron.
I'm sure that I'm not one of the products.
What was the question again?
What is better than a relational database for full text search? Elasticsearch, right? But how can I use Elasticsearch when all my data...
Introduce latency, just use Postgres' exactly what we just said, the full text search. Doesn't it have one built in?
It does, but it's not as good as Elasticsearch.
Even with all the latency and the cost?
Mm-hmm.
Okay.
For sure. How could I hook up Elasticsearch to this? Oh, I know. I could have an aggregator that's there to handle my search.
You just sell your soul to the devil.
Yeah, but you get better search results, which is exactly how Google works too. So again, here is a simple aggregator. These are pretty small files. This is 48 lines with white space and no comments, because who needs those with descriptive function names? Anyway, so we register when a product is added. We need to index that, stuff it into Elasticsearch. So we call into it and do that. I am no Elasticsearch expert. I know that it exists, know how to pull down a Docker image for it, and shove something into it. So that's what we have here. And then, of course, we need to turn the aggregator on so that it can pick up all the data from the beginning of time. And then it will do that thing there. And then this search is on the description, so I want to find things I can eat. Let the CDN stuff time out. Boom. Hey, look, there's a product I can eat. And then if I want to search tuna, I mean, you know how search works. I don't really need to dive into that. Why is this cool? Well, the product data was not available at the time we added Elasticsearch to the system. You might be thinking, okay, but if I had a relational database table, I could have done the same thing. Yes, you could have. What advantage do we get here? One is I didn't have to change any of the existing code to make this work. Two, now as I'm going forward, if I'm just doing the old relational database way plus Elasticsearch, I have to write two things to make this work properly. The request has to come in to add a product that I then put into the database. Then I need to make a separate call to Elasticsearch to get it indexed. What if it breaks right in the middle? Now they're out of sync, and that's not so good. With the event model, I just write to the event log. Now the state is secure, it's in place, and the aggregator pulls that into Elasticsearch. Yes, they could be out of sync by a few milliseconds, but the point is, like, I know how to recover from that. Whereas if the products table and Elasticsearch get out of sync in a more traditional model, who's right? What if they disagree? How do I reconcile that? I don't know. But with the event stream, I know what the authoritative state is. That one write has captured all the writing I need to take care of. This is now just a read concern.
So real quick, let's say that in the middle of, writing to it, and the aggregator is going to do some stuff, and the database still quits. What is ensuring that that write is retried?
So if the aggregator fails its write, it keeps a track of the last thing it successfully processed. So if it has not successfully processed it, it will try again from where it left off. And then if the event stream is down, it can't advance either because it can't see new data.
And I missed the first part of this, so are you using a specific library for the event stream?
Just this project right now is just using a Postgres table to store all the events, but there are dedicated solutions like Event Store. It's all one word, eventstore.org. Great data store, but yeah. So I don't have an example of it here, but now let's say you were doing something like LinkedIn and you wanted to know information about all your connections out to 6 degrees. And you have a schema that captures these relations in a relational database. Anyone want to take a guess from a scale of 0 to 10 of how painful of a query that could be? Because you'd have to query me for all my connections, then loop through all my connections and query for all their connections, and so forth out to 6 degrees. Yeah?
Did I build this with nested sets or an adjacency list?
Say that again?
Did I build this with nested sets or with an adjacency list? I work for an MLM, so querying trees of data is our bread and butter. So
you could do either, I suppose.
Poking fun at that.
The
short answer is it's enormously painful either way you go.
Yeah.
And it always sucks unless you're LinkedIn and you've engineered for other solutions.
But that's the very point. Every database sucks for certain use cases. Event Store sucks as a read model. It's a really bad one. How often do you really just need the list of every event that happened? Rarely, right? It's a terrible read model. It's an awesome write model. You just write, boom, you're done. Relational databases are really awesome for OLAP type stuff. They're really awesome for data warehouses. They suck for graph problems. What is good at graph problems? What? A graph database. Yes, exactly. Could I hold that thought while I pull this back up? And could I take this data and somehow inject it into a graph database?
I'm betting yes.
You could. It's just another read model, and it has access to all the original source data. So graph databases are really awesome for graph problems. They suck for other things. They're built specifically for that. I can laser target my read models for whatever application I need to do because I have this one common source of authoritative state, and then I can do whatever I want for the read models. Now, that said, just because I can introduce a new database for every kind of read model, should I? I don't know. Every new thing you bring in has a cost. You need a team who knows how to run it, how to back it up, etc. So if you're dealing with like 20 rows, do the nested sets or adjacency lists. That'll work just fine on 20 rows. But when you start getting into millions, you start needing to have special solutions for that kind of a thing. And then lastly, obviously these are not new ideas for me, but how many of you have heard of a website called Twitter or one called Facebook?
What's that?
Horrible waste of time in both cases. See what? Yeah, pretty much. And that's what most of what people put into the site looks like too. But have you ever wondered how they so quickly render your timeline? Do you suppose that when you load up the page, they check to see who you are, then go query all your friends, then go see all their posts and quickly assemble that into a timeline?
No.
They don't. They're doing this exact process we've talked about. They have something that's observing events getting published, and they're writing it into something else for quick retrieval that doesn't have CDN timeouts, so the load time looks way more impressive than the better admin dashboard did here tonight. So I guess just to wrap it all up before questions, like I really love microservice architectures because, oh, this is going to take so long to get back. It's slower to start out with them, yes. If you need something up in 10 minutes, something like Rails or whatever node equivalent, it's going to get you there faster. But over the long haul, their difficulty of making changes doesn't go up nearly as quickly because the pieces of the system remain isolated. One thing going down doesn't bring the whole system down. A change here doesn't affect changes in who knows where. And so that's really good. But one of the things I really love is this concept that I can have this one set of authoritative data, but then if I need to shape it in a different way than you do, we can each do that. And that's fine, because honestly, we're oblivious to each other's existence anyway. And that is really, really powerful and solves a whole lot of problems, including like trying to do graph queries in a relational database. The wrong model leads to a lot of accidental complexity, as Greg Young, he's a big speaker in this space. But with the event streams, we can choose the models appropriate to what we're trying to do. So that is, I think, the conclusion. Let me just make sure. So many buttons. Oh yeah, so here's some information of stuff you could look at next. Yeah, any questions? Yeah, Corey.
So, I have a question that goes back to the right side. As the duration of your application gets longer, you get a larger and larger amount of storage than terabytes, petabytes maybe, I don't know. What's the common solution for maintaining that, and are there avenues, somebody answers this, avenues to spinning up new services that get, I have to read through the entire thing, there are ways to make that efficient?
Okay, so there are multiple parts to that question. The first is an append-only log of immutable events. There's a concern of storage needs growing. How do you deal with that? And then the second one is when you bring up a new service, it has to chug through 2 years of history. How do you deal with that?
That's correct.
Okay, awesome. So the first one is a great question, and usually one of the first ones I ever hear, so it's a good one. Greg Young, another guy, he phrases it this way. Where does your rate of data ingestion sit relative to Moore's law? So 10 years ago, I don't know how long ago, but when I was a kid, I remember we had like a 4 meg hard drive. It's like, oh my gosh, how could you ever fill that? And it was like $1,000 or something, I don't know. But in that camera back there are a couple 64 gig SD cards, and that was like $20 for one of them or something. Data storage gets cheaper over time, and if you're not accumulating data faster than it gets cheaper, then really you don't have a problem. If you do, you might need to look at other solutions. So Event Store in particular supports clustering. So you can have different nodes that all have their own storage, and so you're not filling up a single server. But if you really are ingesting that much data, you're probably in the 1% of apps versus the 99%. And so more specialized solutions would be needed at that point. Now the second part of your question is, what if you bring up a new service? Our product search thing had 3 whole events to get through instead of 2 years of them. It can take time. So when you bring up a new service, kick it off on a Friday, come back Monday. I mean, that's what I'd say. Like when you start up the new service, it'll take it some time to catch up to the present. That won't happen instantly. And that's just an accepted part of it. Does that fairly answer your question?
Yeah.
Okay, 1 second, Aaron. There was one over here. Okay, yeah.
You should totally take this question first.
Okay, Aaron, back to you.
In previous presentations on this subject, you talked about the ability to aggregate
Yeah.
the result of, take a snapshot essentially of what the result of the event store at any given time might be. And it seems that would be a convenient thing to do to speed up bringing events online, bringing new services online, as you kind of say, well, I've rolled it up. If what you're looking for can start from this point.
There you go. Yeah, that's the caveat there. So if you're doing very different views, like we're finally bringing up the Neo4j aggregator, a snapshot that was going to Postgres isn't going to work for it. So the different aggregators have different views usually of the data, and so a snapshot from one wouldn't be very useful to another one. Those are insanely useful inside of a service. So if I need to do validation right now and I need the current state right now, then a service might have a snapshot of what it cares about, and then it would just need to apply a few new events. But if I'm bringing up a whole new representation of it, there probably is not going to be a snapshot that matches it. You bet. Okay, yeah.
Actually, a great example of that, Family Search is actually the only example I've heard of here in the Valley that uses the CQRS model. And I know what they did is they actually implemented the whole thing in Cassandra. So their event store writes into Cassandra, but then they have multiple snapshots to build on top.
Okay.
So they take a snapshot of the output of all of the individual commands to create a single user record, and then they'll aggregate those user records up into different views to be used for the read models. Which actually leads me to my question. I've talked to a lot of people that use Kafka, that use various different solutions. Kafka, of course, is by default designed to only store like 7 days worth of data or whatever. And there's a lot of people out there that argue that the event store concept, while nice in theory, ultimately breaks down. Like I said, Family Search is the only one I know in the Valley that actually has that, and they built a totally custom solution on top of Cassandra. Do you know anybody else that's actually running an event store model with a full CQRS implementation in production?
Jet does. Jet.com.
Oh yeah?
They're a competitor to GDoom. They're an e-commerce store. They're a bit more successful than the one we looked at here today. But yeah, they recently published an article about using event sourcing for stuff. They don't have a single event store, like they have different sections that have their own, and then a global one for communication between the different sections of the business. So they're an example. eBay recently published a thing about using event sourcing, which is a great fit when you're dealing with money. Immutable logs of what has happened, that's fantastic to have in banking. That's probably what all of our banks do. Your balance isn't just a column in a database, because what if I disagree with my bank? Well, that's what the database table says. But they have the full list of all the transactions. Heavily regulated industries are going to favor things like this. Gambling. Greg Young has done a lot of work for gambling projects. So yeah. Just an example in everyday life, like legal contracts are event sourced. Like if you go to buy a house, for example, you'll make an initial offer, and then the seller will counter offer, and then you might accept it. But their counter offer comes as an addendum to the contract. They don't just go edit the contract. There's an addendum.
Yeah.
But
there's lots of real world analogs for it. I was just curious if you knew of any other tech companies that were actually running an event store for their actual database backing.
yeah, so Jet and eBay are the ones that come to mind. I will count them both as Valley companies because they have a presence in the valleys, if not headquartered here.
Sure.
Okay. Yes?
Any kind of a blockchain is built on the same concept, where it's a series of transactions
That's right.
that can be replaced on the
With different guarantees than, say, a Postgres one would have.
Yes.
But you don't need a blockchain.
That's true. You
Oh,
don't.
oops.
There's not any circumstance in which a blockchain is an efficient or effective solution.
Corey, did you have another one?
More of a comment, I guess. You mentioned earlier that this requires kind of a different mindset to things, and so I want to try to restate something and see if it's accurate.
Okay.
So in your traditional kind of model, you have your databases that sit in the center, and they act as these sources of truth for different ideas. You have services that connect to them, and then that communicate out to things that display the client. But those databases are the sources of truth. In an event source model like this, you have your event source, which is the source of truth. You do not lose databases, but you repurpose them in a much more specialized manner. areas,
Mhm.
particularly when you're talking about as stores for view models. Is that right?
That's right. Yep. Yep. So you can use all the tools you were familiar with. It's just instead of populating them directly during a request response, you just write it to the event store and then later turn it into the read models. Good question. Yeah.
So I'm working on implementing events store, well, Event Plus at the moment, and the people we're working with really, their idea is that the domain objects are not events, but like actual, user domain object. You get a snapshot of the entire user. It's kind of a lot more like having user created, user updated. In your experience, what do you lose if you go that route instead of having more semantic domain events?
Okay. So one is, until you start working with it, you won't appreciate the answer. I didn't at first either. You lose the intent of what was going on with the event. So if you're just like, here's what the user looks like now, here's what the user looks like now, why? What was the user trying to do? So it goes back to that something changed, something changed, something changed versus events explaining what was actually going on in the system. So debugging becomes more difficult. If you're trying to put out fires, it's more difficult. You really need to be one of the programmers to understand what's going on, whereas a list of domain events, a non-programmer could look at that and be like, oh yeah, I get what's happening here. And so it seems like a really subtle, small point, but when you start working into it and realizing how useful it is to capture that intent, like it becomes a really big deal. The other is being able to do these cool transformations into the different things. I find that they're more difficult if I'm publishing full-on materialized views of a given object, because now I'm kind of coupling to this one shape of it versus coupling to an event contract of very granular state changes in the life cycle of these things. Does that make sense? So like,
Yeah, so can I ask you a follow-up question?
yeah, please do.
So let's just pretend for a second though that I've got a database that's my destination for rendering this data off of the bus. And so if I've got like multiple different domain events all writing into the same table, how do you handle conflicts between different events and that they all hit at different moments and guaranteeing that you have all the dependencies met to be able to perform any insert of the operation?
Good question. So this is all assuming that within a stream, events are always processed in order. So a user shut down their account couldn't be processed before a user registered. So streams are partition points. Within a stream, ordering of processing is a guarantee in a system like this. So that's...
You have different consumers at different points on the stream.
They would never write to the same locations. So if I'm aggregating over here, no one else is doing that. Like I'm the only one writing to this location. I could write to multiple locations, but no location is written to by more than one aggregator. So there isn't a chance for a conflict.
So you're saying you have, so in my case, we're writing lambdas.
Okay.
And we've broken up the lambda so that I have a lambda that's writing all of the data pursuant to one event, another lambda that is writing all of the data, but into the same destination. Are you saying that you would have just one single lambda that would handle all of your offloading into that destination database then?
More or less. Let me restate to see if I understood what you were saying. So are you doing lambdas that process a given event type?
Yeah.
Yeah, I wouldn't partition it that way. So I'd partition it by the entity in the system that's represented by it. So I might have one, like we had here for user credentials, like it happened to only have one event that it subscribed to, but it observes user streams. So each user has his or her own stream, and then an aggregator observes all the events for a given user, rather than having an aggregator that does a specific type, because now that ordering isn't guaranteed anymore. I have to have that guarantee of ordering for this to work. And so the way you do that is partition by stream rather than by event type.
Are you saying you create a stream per user?
Mm-hmm. That's right. I would. I mean, that depends on the system, but a user would be a common one to get its own stream. And that question in particular is actually the biggest reason why I don't like something like Kafka or RabbitMQ for a system like this, because streams roughly correspond to topics or channels. I forget which one calls it which, but you kind of have to know what those are when you first start your system. Like in Kafka, it's really hard to dynamically create a new, is that a topic in Kafka?
I think so.
Okay, it's hard to dynamically create a new one, but in an event source system, like you can have hundreds of millions of different streams, and that's just fine. So I mean, my recommendation would be don't partition by event type, partition for streams, and then in the case of an aggregator, for what you're writing to. Yeah.
So, but in all of these aggregators, then you always build with the assumption that your events are going to come through in order, and you're not trying to handle things happening out of sequence.
That's right, because I build it in such a way that that can't happen. The one other part that comes to mind with that is like if you and I sitting on a web page for the same entity try to submit changes at the same time, that could create a conflict, like who clobbers whom there. And so you can build optimistic concurrency into systems like this. And so an event stream will likely have a version. And so it's like, well, all these events were published at version 3. I'm going to publish some more. I expect the stream to be at version 3. Oh, no, it's at 4. OK, reject. But now with granular events, maybe what we were doing didn't actually collide, and so I can resolve that gracefully, like how Git can do a merge automatically. But if I don't want to put the time into building a system like that, or if I can't tell, I can just punt back to the user, hey, this changed since when you submitted this, so try again. I mean, that's up to the system to decide what's right. Not the system, the people making the system, obviously. Like, it becomes self-aware and says, no, I will reject all version content. But good questions. Are there any others? I think we will all be happier in a moment when I stop talking, but thanks for the questions and for listening.